Afternoon. I'm Astha Chawda, and my colleague is here with me, Shriyar Shah. So, we are from Intel, and we are here to tell about the embedded controller firmware performance profiler tool, which we are using for our debugging purpose. Yeah, can you see this next slide? Okay, so this is the agenda of our presentation. So, first we'll go. I want to introduce about what is embedded controller in Intel. So what does it do in our Intel RVP platform? RVP, when I said RVP is the reference validation board, and what are the functionalities handled by the EC, and then we'll go to the problem statements, why this tool needs arise, and the solution, what we did, what we developed, and followed by the results, and we'll conclude with the future scopes and the conclusion. The next slide. Okay, so as you see into the diagram, okay, so there is a Intel RVP whole is the Intel reference validation platform. We call it as RVP. So here we see that the EC chip is on the top of the motherboard, which is talking to the CPU through PCH via eSPI interface. So it's not directly communicating to the CPU, but through the PCH we are communicating. So here we have the many functionalities which is handled completely by the EC. So say for example, the power sequencing, battery management, thermal management, fan, and buttons. So LEDs also, PS2 mouse, or the keyboard and the scan matrix. So all the modules is handled by the EC. And one more thing is EC is the first chip on the hardware who is receiving the power when we press the power button. This is only I'm talking about the Intel RVP. Okay, so we'll jump to the problem statement. So okay, so we saw that in our regular day-to-day life, okay, when the developer is releasing the firmware for any of the Intel platform like Meteor Lake or the Arrow Lake, Alder Lake, right? So what happens sometimes, okay, build is done, release happen, and we start the validation. But in some point of time, because we always have the memory constraint in our embedded system, we have the limited memory usage. We don't know that if the stack overflow occur. So in the middle of the validation, sometimes happen that we get to know, okay, the autos crash happen. Okay, and again we need to do the it's a regression happen, and developer again need to deep dive into the each modules. Okay, what happened into this? Which module it occur? So using this tool, we are uh, overcoming this kind of the situation much earlier than the firmware release. So this tool can help to give us this RAM usage data, stack overflow, worst case stack scenario, and another more important is that data structure whole detail also. So we can utilize the memory very efficiently. So this is why we have developed this tool using the some Zephyr optimized tool itself. Yeah.
Importance about the external debug.
Yeah. Thanks to give this point. So yeah, we are using the very minimal hardware to use of this tool. So I think almost whichever in the market for the performance profiler, we are not using this kind of the hardware. So this is independent of that. So we'll not need any other external hardware to have this performance profiler tool to be used for your setup. Okay, so before going to the solution, I want you to tell more about the Zephyr tools which we are using here. So there are some prerequisition which you need to take care of to run for to get the stack details or the data structure whole details. So there are the tools which is supported by the Zephyr. That is a third party tool actually. They are calling it as the puncover and pahole. It's actually mentioned here in this section, worst case stack usage data and data structure whole. So when I say the stack usage, it is Sapphire call it as puncover. Puncover is nothing but the third party tool which you need to run after you are building your EC firmware code. And the another one is the pahole. There is a data structure hole that gives us the how much hole your data structure is data how many holes is occurred during the your data structure when you are adding into your EC firmware code. So these two things and another third things which we are using to get the runtime stack and CPU usage data, it's a thread analyzer. Again, the thread analyzer is given by the Zephyr itself. So we are utilizing this optimized tool to develop our profiler tool. Okay, so these are the prerequisitions which you need to done in your setup if you are planning to you if you are planning to get this data. Okay, so as you see here, the first point is the EC firmware build once your application is built. Okay, and we have the automation framework. Another point is we have integrated this tool to our automation framework, so we can run it overnight also. So first step, EC firmware application build happen, and that is Python run. We have the Python script already, which is already have the command which is necessary to be done, which is necessary to be run to get the pahole puncover data. And after that, once the actually this is the EC firmware binary, once the developer have pushed to the we have the SharePoint. Okay, so once this pushes happen to the SharePoint, then our script will go and repeatedly check, okay, so binary is done. Okay, then now let's start with the automation framework and run the necessary command which I already mentioned. Okay, this is our profiler tool. So this is the tool, and as you see here, we already have the setup here, and we have the serial cable here. So necessary logs is already collected by our automation setup only. And this tool, once all the data is collected, then at the end we are displaying this to our dashboard. So no need to run like whenever the release happen and the resource goes and go to the lab and check every time what is the situation of this particular binary. So just we need to go and run this automation frog that is automatically run all the information once the binary is pushed to the our SharePoint. And we are displaying some SX cycle power measurement also. This is not like we are using any Zephyr tool, but this is in ourselves we are doing. And yeah, this is the solution which we have developed using this tool, and I want to show you the results. So yeah, this is the dashboard, how it looks like. Here on the top you are able to see that the which of the binary, and another one is that which of the Intel RVP is you are targeting. And this is the stack usage data of the RAM. Another one is the puncover data. As you see here, it will show module by module because we have the many modules to be done using the embedded controller chip which we are using. There's a microchip. Okay, and so each of the module by module you are able to see the list down of the all the stack usage data. And the another one is also the structure, data structure whole. So here also in the each of the files of our source code, it will be listed down here. And yeah, the next slide, please. Okay, so we have the stack graphical representation also we do have. So here, if you see that the stack usage data for the battery or the PD, it's already listed here. Say for example, sometimes what happened that I can give you the example. If we have allocated 1024 kilobytes of the memory, and we are stressing out our system, it will not like that we are running just one test case or the two test case. Overnight we are running the SX cycle, and sometimes at that time only the stack overflow happen. It will utilize the memory, it is not allocated at all, so auto crash, right? So using this will it will show it much earlier than the actual validation happen. So it will go, it will pop up and it will highlight it. Okay, this is the how much you allocated, and this is what exactly your while you are running the code, this is what happened. So this is actually the helpful in this kind of the scenario. Yeah, can you go to the next? Okay, and this CPU usage time versus CPU usage. Okay, so we have the another graphical representation for the each of the thread, because we are having a many threads for each of the modules, and we want to make sure that ideal thread should be run maximum times, right? Ideal thread should be run maximum time, because if nothing is running on, then ideal thread should run for the maximum time. So we are collecting how much percentage of the CPU usage happen during this time, and during we are stressing out the system. So this is what we have shown as a part of the tool itself. Okay, so as you see in our whole presentation that this tool is quite useful when we are having a constraint of the memory and we are having a very bulk application in the very bulk level, because we are handling a many kind of the modules, and again it's keep on increasing, like type C USB, which also is increasing, so it will keep on burden on the system. So we need to make sure that our memory utilization happen correctly. Stack overflow should not occur. So this kind of the things we are we are taking care using this tool much earlier than the firmware release. So it's a very big and major benefits for our regular releases. And yeah, we are planning much more of using this tool. We are planning to automate it, displaying of the power consumption SX cycle, which is right now on the manual. So we are working on that. And yeah, so this is the references which I have listed here. The first one is the optimization tool, which I have told, pahole and puncover. You can go and check it out in the Zephyr website. You can exercise it also, because it's a very, I must believe it's a very useful when you have a very big source code. And another one is the thread analyzer, which I also mentioned. And the last two is the open source easy source code. So Intel do have some of the functionalities. Its source code is open source, so you can leverage, you can use, and our documentation is also in open source, so you can use that and to your exercise or learn more for that. Yeah, this, thank you so much. So my presentation is done. So you have any questions related to this, you can ask us. Yeah.
So you talked about connecting the stack traces.
Yeah.
So how do you extract the data from the computer? Because your script is running on a different machine, right? So how do you extract what is the content?
Are you asking about the stack usage data?
Yeah, correct.
How we are extracting the stack usage data from the source code?
No, from the embedded controller. You are running on the PC, right? So how do you extract the data? Are you using some IPs in the system?
No.
During the compilation, what we do is we will generate object tags. So nothing also will be provided as an
Input.
to the puncover tool, whatever she explained. So that tool will actually start one more thread, and then it will collect all the means we have different threads for battery, we have different threads for thermal, CPU, all the means we have once the main application will start, all the different threads will start, and then each thread will have their own stack that is being allocated. So this thread will go and monitor that. Okay, means battery management, how much thread means how much stack it is going to use, and all these things will be populated, and then to using this tool, we will give that graphical representation. That's what but this tool is running on the DC. Yeah, this tool, this tool is running on DC. Okay, but DC, how do you extend that? No, we have this serial port which will be connected, and then along with that the object file, because during the compilation only we will get to know means what's the maximum allocation of the stack that needs to be used by this particular thread. So based on that comparison and all, we will be getting this values. Puncover is more of a static analysis tool run on the ELS file, and it extracts this information based on the amount of functions which is called. It's not about running the controller and extract this information. Instead, it is on offline. You can say static analysis tool.
Yeah, using the puncover, it's a static analysis, but thread analyzer, we can use it for the runtime usage, because we are using thread analyzer for that. Anything? Yeah.
Is that training stats from remaining threads, right? Does it add significance over into the system, or it's very lightweight?
Yeah, so it's again the subjective topic. So it's a lightweight, I can say, and it will not affect our system, because yeah, thread analyzer when we are using, so our application is already running with many threads, and on top of that, this thread is coming and visualizing the what is happening in this thread, right? So it will ideally it should affect, but as per our we are using over the since 1 year, so it's not affecting at all.
And suppose and also what they are doing is we can utilize this thread for
5 seconds
5 seconds kind of.
polling.
So it's kind of a polling what it will do. And then even the small documentation says that it's the maximum or the minimum what you can use to run this extra thread to extract this.
Yeah.
So how does this basically monitoring thread pull the data from all the things? Like based on the timing base or
Yeah, we are polling 5 seconds. as he mentioned, right? It's mentioned in the, if you go to that link, right, you can get in more detail.
We have not
No,
explained that,
yeah,
but generally for all the firmwares, we can reutilize this tool. But for networking things, yeah. So we can utilize that along with means the existing repository. Yeah,
yeah,
yeah, I think we can do that. Crash dump collection also as part of this.
that is, we are planning on our future. This is, we are working on that. It's our future plan. Crash dump.
It's an automatic thing what we have done.
Yeah,
Automatic crash dump analysis. Dumping and then analyzing the data. Could you go back to that blog dive?
yeah, sure. Which one?
This one. Yeah, this one. Okay. So this EC chip, right? That is where you flash your this firmware. No, no, we no, we have a spy flash. Okay, a spy device with that. So all the firmware will be flashed over that. So EC, it's a microcontroller. What it will do is on the boot up, it will try to get the image from that, and then it will load to the internal. So that's how the thing happens. Yeah. So if some other vendors want to make use of this one part, so what all blocks are needed? I mean, for example, another vendor wants to do this profile. Yeah. What all of these blocks are required? I mean, outside blocks understood. But inside this, so where should we run this the firmware to do this profile? I mean, extra task and all that. So it has to be built together with our application. Yes.
Yeah,
So
so
once you are doing, good.
okay, so because I tried standalone also, not with this automation framework. So when I tried, it's like after building our applications, we have the specific tool which is supported by Zephyr, right? The puncover and pahole. Just need to install that and run the specific command which they have given. So it will be listed down all the things, static analysis, and this runtime also. But you will not get, because we have the many lines of the codes and we need to exercise all the source code. So that's why we need to put it in the automation framework.
Is there any plan to open source this tool?
No. Yeah.
Because like the tools what this is using internally is kind of borrowed from.
Yeah, but we, you can leverage this our puncover and pahole data, which is supported by Zephyr. Another thing is our source code. Some of the feature is open source. You can use of that, but this tool is not yet open source.
And suppose if the use cases stand on the EC side, right? Let's say today we have 5 or 6, but tomorrow say something else get added.
Yeah.
More on the EC side.
Yes.
How is that taken care? So is that all like scalable from the profiler, or like say we have to have some additional changes to be developed?
We already thought of this, so that's why we make our source code like that. It's configurable, so we need to add the minimum changes in the tool itself. I mean, profiler itself. So we need to just add the files as Shiyasha mentioned, right? This we need to generate the object file, and we need to add some of the modules which I mentioned. So I need to just add into the script. That's it. Otherwise, it will take care of the building once I build the easy firmware.
Supported on the EC hardware. So what we are doing is we will anyway this will give a developer an insight that okay, this is the amount of RAM or the stack that is really being utilized by the application whatever you are having. So we need, if we need to support some new application or any new implementation, we need to go for a higher version EC chip. So there you have even more bit of more RAM or capacity, so that we can try to add more new features. So that means this will give an insight to the developer. Okay, we are running out of the memory, so we need to move for a newer version. So like that only we did previously. It was different series altogether. And if you want to exercise more about USB-C applications, because nowadays the Type-C is the one which is going on in a quite of a lot of book. So in order to actually have all those applications, we need to have a newer version of the EC, and then that will go to the we have replaced that, and then we have extended our EC applications.
Okay. Thank you, everyone.